All right, welcome everyone. Welcome to my presentation on maintainable test automation. Like I just said to Sjoukje, this presentation was inspired basically by test automation projects that both Maarten and I worked on, where we saw that it didn't quite deliver on the return of investment that was expected, or deliver on the expectations as a whole. So what I'm going to do is I'm going to give you some tips and tricks on how we feel that you can keep your test automation project or implementation maintainable. But let's first start with some introductions. My name is Joost Arends, and I live in Amersfoort, which is a beautiful city, as you can see. And like I said to Sjoukje, I haven't been into the testing profession for that long. I actually started my career in education. I've been a chemistry teacher for about 6 or 7 years. And in that time, I did a lot of things. I worked mostly in secondary education, but also in higher education. I co-authored a couple of books at an educational publisher. And at some point in time, I figured I've done most of the things that I would like to do in the educational field. So I was on to a new challenge. And more or less by happenstance, I got into contact with a recruiter and I ended up at Capgemini. And I've been enjoying my time there ever since. I immediately specialized into test automation, which we all know is a field where there is a lot to learn, a lot of challenges. So I haven't had a chance to get bored yet. Like I said, I would do this presentation with Maarten, and we both worked very hard on this presentation and on the tips and tricks that we would like to provide you. So I wanted to leave this slide in just to give a little shout out to Maarten. And I'd say let's start. If you look at the main topics that I would like to address tonight, I would first like to talk about the common issues that both Maarten and I saw on the projects that we worked on. Then we're going to dive into a little bit of test automation architecture, because we believe that is an important topic to make your project successful. And what we did to give our presentation a little bit of body is we put the tips and tricks that we saw into a sort of commandments, which happened to be 8 of them. So we titled those the 8 commandments of test automation, which will be the main topic of this presentation. So let's first dive into those common issues, with the first being reusable keyword-driven steps. And we're talking about the test specification here, which for most of us would be in a given when-then format or in a Gherkin format. And what we saw on a lot of projects is that those keyword-driven steps were implemented in a way that they were reusable. So they were on a very atomic level, and you could use the same steps on a lot of your test specification, a lot of your test scripts that you created, which sounds like a good thing. I mean, reusability is an important topic in the IT world. But however, for test automation, what we noticed that the effect of this is that the test scenarios ended up being very expansive. So we saw test scenarios consisting of 100 or more separate steps, which turned out to which made it so the test scenario didn't properly describe or wasn't clear in what was actually being tested. So what was the action taken? What was the expected outcome? That sort of stuff. Another issue that we ran into is dependencies between test scenarios. So imagine that you have one test scenario that as a part of its scenario, part of its test, it makes a change to some piece of test data. And then you have another scenario that in some way or form is dependent on that change to be successful. This means that if for some reason the first test fails, the second test will also fail, which isn't that much of an issue if it's only 2 tests you're talking about and you know about the dependency, but it can become an issue quite easily when there's a lot of dependencies between your tests and you don't know about the dependencies after a certain amount of time. And finally, one of the major issues we saw is when looking at test automation frameworks or entire test suites, is that after some time, they turned out to be these huge, complex, untraceable things, where no one exactly knew what was supposed to do what and where the responsibility lie for certain actions, or where nobody dared to make any more changes to the framework because he simply didn't really understood how it worked. Yeah, so that's a definite example of something you want to avoid. So, looking at these common issues that we saw, obviously we learned from them. We try to create solutions for them, and I would like to present those solutions in the remainder of this presentation. Now, keep in mind that, and it might be redundant to say, but obviously there is no such thing as best practices in test automation. There are only good practices within a certain context. So what we saw, that the recommendations that we're about to give you turned out to be good practices in our context, on our projects, the type of applications that we worked on. But by no means are those recommendations any sort of law. So please take the recommendations that I'm about to give you and apply them to your own project if they are useful, if they add value in some way. Let's start with the first issue, and that is test architecture. Because what we saw is that there wasn't a lot of attention beforehand on how a test automation architecture should look like, what kind of levels there are, and what the responsibility is of each of these levels. What we noticed on most successful implementations is that there's a clear distinction between layers, with the first layer being the system under test, obviously. Now, this also isn't a layer on which you as a tester or a test automation engineer will be actively working on, but it is important to understand how your system under test works. What kind of access layers you have. So do you have a UI? Do you have certain services? Is there a database? That sort of stuff. And once you understand your system under test, you can start building a test framework or use an existing test framework in which you provide methods to operate the system under test. So if you have a web-based UI, you probably want some sort of WebDriver in your test framework. If you want to call services, you might want an API library, that sort of stuff. The next layer in the architecture is the actual test implementation layer. So this is the point where the actual technical implementation of your tests will be written. So for those already a little bit accustomed to test automation, this is the point where, for example, your steps or your pages will be in. And the test implementation only uses functions from the test framework. So it doesn't speak to the system under test directly. It only calls the test framework and basically delegates everything it wants to do to the test framework. And the test framework itself then talks or operates the system under test. To perform a test, you probably need some form of data in most cases. So there's also a test data layer with some form of data generator, or it might even be some sort of hard-coded data in some way or form. But your test implementation needs some input to provide to gain data in which to use in your test. And then at the top, you also have the test specification layer, which for a lot of us will be in a Gherkin format, which I talked about earlier, and which is a main topic of this presentation. And what you would like to do is actually keep a clear distinction between your test specification and your test implementation. So the test specification specifies what is being tested, and the test implementation provides how it is being tested. And the final layer, very important, is a test reporting layer, because obviously once you run your test, you want some sort of reporting, some form of way of knowing how your test performed, which tests are passed, which tests failed, and why those tests are failing. And the test reporting layer makes use of feedback from all the other layers in providing a clear report. What we saw, if you look at the test effort that you have, is we sort of see two sides to this architecture. On the one hand, you have a create side. This is where the primary testing effort will be. So this is the side where you will be creating new tests, where you will be implementing those tests, where you will be thinking and providing test data, that sort of stuff. And on the other hand, we call this the use layers, which is the test framework and the system under test. These are mostly layers which you set up once, and then you probably won't be touching a lot after that. Which isn't to say that you will never be touching your test framework ever again, but once you've set it up initially, you want to set up in such a way that only when a change in your system under test actually requires you to change something in your framework, that's when you will be tweaking it. So most of your test effort will simply use the services provided by the use layers that are already in place. This might be a little bit abstract, so let's take a look at one of the most common seen test architectures out there in the field, I guess, which is the page object model, which again consists of several distinct layers, with the first being the features, which describes your test in a business-oriented language, such as given when then. The features then are implemented into certain steps, and those steps provide the functional implementation of your test scenarios. So every keyword in a feature file will be implemented in a single step. And what you would like to do there is keep it as functional as can be. So the method calls that you will see in the steps layer will be, for instance, log in as an admin, fill out a form, verify a message. Method calls that even for non-technical people are still understandable. Going one step further, one layer further, you will find your helpers in your pages, which provide the actual technical implementations of the methods called from the steps file. So here you will be actually calling a WebDriver, searching for elements on the web page, clicking on buttons, that sort of stuff. The test implementation layer, which I talked about in the test architecture slide, those are actually the steps and the helper pages layers together in this model. One layer further, the helper and the pages actually make use of services provided by the framework. So the framework is responsible, for instance, for providing a WebDriver, for keeping track of which WebDriver you want. Do you want a Chrome driver or a Firefox driver? Which version do you want? Do you want it to be headless? Do you want it to be mobile format? That sort of stuff. That's all the responsibility of the framework. And obviously the framework then talks to the system under test to actually perform the test. Keep in mind that while the page object model is a very strong architecture, which is also the reason why you see it on a lot of projects, it is by no means a silver bullet for every project there is. There might be other architectures such as Screenplay, which are more beneficial for your type of project. And also you can take an architecture and tweak it to your own needs. So let's say, for instance, you have a microservices architecture with very small applications. Is it then really necessary to keep a clear distinction between steps and helpers? Or can you provide this in one layer? I don't have the answer, but that might be something worth looking into, that sort of stuff. Again, there are no best practices, only good practices within a certain context. So that's to say, the test architecture is something as a first step, something you want to think about, something you want to make an educated choice when first starting your project. But simply by using a proper architecture isn't enough to keep everything maintainable. So what we're going to do, we're going to dive in what we call the 8 commandments of test automation to see what else is necessary to keep your tests maintainable. But before we dive into those 8 commandments themselves, let's first take a quick look at Gherkin, because that is an essential part of the remaining slides. And Gherkin is used, well, so far on every project I've been on, but we also saw a lot of different ways in how Gherkin was used. So it might be good to give a little bit of attention to that. And Gherkin provides 3 different keywords, given when then, with given being your baseline, every precondition that you need when performing a test. Then the when step will be the actual concrete action that you will be taking. So what is the action that you want to see the outcome of? And the then step being your actual expected result. It's as easy and as simple as that. So what we say is don't make it any more advanced or any more complex than this. It's supposed to be a concise way of writing tests, so keep it concise. And to prove that point, let's take a look at this scenario here. This is an example of a scenario that we encountered on a lot of the projects that we've been on. So here you see those small atomic steps that I've talked about when talking about the common issues. So you have a step for clicking a button, for clicking on a link, for filling out a field, that sort of stuff. It makes the steps perfectly reusable. But if this ends up to be a scenario with, well, a lot of steps, and like I said before, we've seen scenario with over 100 steps, then the whole point of writing your test in a concise format is lost. So what we say as a first commandment, a typical scenario should be 3 to 5 keywords long. If you take a good look at the scenario that we have here, if you take a look at this entire first part, then the whole point of all those steps here is to go to a certain contact form on a certain page and fill it out. That's an actual action. So in our case, this is actually a single action. You go to a form, you fill out the form. That's it. So instead of going through all the different steps, you can just go to the form directly, and you provide, in this case, one step to go to the form and fill it out. And your expected result is then only, then I expect to see a confirmation page. So by doing it this way, we transformed this expensive scenario to a single scenario of only 2 steps, which is a lot more concise and a lot more readable, especially when collaborating with other people on your team. Another example when talking about atomic steps, and something we saw a lot, is a scenario such as this. The whole point of this scenario is to test whether removing an item from a shopping cart does the right things. But obviously, if you want to remove something from a shopping cart, then you need to have added something to the shopping cart first, which is, in this case, what the first half of the scenario is. But that also means that the scenario actually does 2 things. It tests whether you can add something, and it tests whether you can remove something. What we say is a single scenario should only describe a single test. So looking at the first part of this scenario, we can separate it as its own separate scenario where you add something to a shopping cart and then you check whether the expected result is achieved. And we pull this apart entirely from the remainder of the scenario where we remove an item. So the baseline condition in this case, which is shown with the given step, simply says the user has 1 item in his shopping cart. Looking at the 2 scenarios on the right, you have 2 a lot more concise scenario, which are a lot more readable and a lot understandable, especially for people more on the business side of things. Going on to another kind of scenario that we encountered, and we worked together on an application which we made use of a content management system. So that means that editors can add documents to the system, which will then be transformed to web pages. So most of our test consists of uploading documents, then actually performing something on the web page, and then checking the actual results on the web page. And we saw scenarios such as this, where a user logged into the content management system, filled out a new document, published the documents, that sort of stuff. But if you look closely at why you need to perform all those steps, the only reason for it is actually just to provide some test data. It's only setting up your baseline condition, only setting up your test data. And what we say is a single test should be responsible for managing its own test data, but obviously in a more concise way. So all those initial steps that are taken here can be consolidated into a single given step saying given a content document. And obviously can provide different kinds of content documents here in this step. So a news page document, that sort of stuff. Which leaves the when step to only when the form in the document is filled And the then step, the user sees a confirmation page. So again, a more concise scenario in which the scenario is itself responsible for its own test data. Now you might wonder, looking at this document, like how do you provide that test data? Well, let's dive a little bit further into that. So let's take a look at this feature file, for instance, where we have a scenario which says given a certain vacancy, when that vacancy is filled, then the user sees a confirmation message. If you take a look at how this scenario or how the single step of filling out the vacancy is implemented in the steps file, then we have the functional steps, the functional implementation that I talked about earlier. So we want to navigate to a certain URL. We want to accept cookies. We open the form and we fill out the data. But obviously at that point, we want some form of data to use to fill out the form. And what we see a lot was expensive Excel sheets to keep track of your data, loading out the test data from those Excel sheets. Well, we say to keep it simple, to keep a single point of truth, manage your test data primarily as code. So how can we do that in a certain step file? We simply say we have a vacancy form data class and we create a new one. And in some way or form inside this class, the test data is generated. And then we can pass that test data onto the fill data method. So you have a single point of truth now. Everything is, in this case, in Java, everything is in the same repository. Another issue that we frequently saw was a lot of test data being put into the scenario itself or into the test specification. While we say only control the relevant test data and generate everything else. So only put test data that actually relevant for your test into scenario. So it's clear when reading the scenario that that's the test data that's in this case controlling, and leave out all the other test data there is and simply generate that. So let's say for this test case, it is important to pass on a certain education level, and there's some other important field for the test where you want to pass in some data. Then only those two fields are passed in the scenario itself. All the other steps, and you see here that those two data points are passed here in the form of a vacancy form data, and all the other data is generated in some way or form. So we pass on the initial data, we say this is the data that actually implemented in the scenario, and all the other fields that are there in this vacancy form generate that data, and then pass on the data to the form itself. What this means is that your scenarios again remain a lot more concise, and also you can clearly see which data is relevant for the test that you're performing at this point. Moving on to another issue that we most frequently saw, and this is something that we saw a lot, especially on web-based applications. In most cases, you want to test your application on multiple browsers, on multiple formats. So let's say you want to test it on Chrome, on Firefox, on Edge, and you want to test it on mobile format, on the tablet format, and on the desktop format. And what we saw was that the test specification was explicitly linked to the platform on which the test was run, or the format. So instead of having a single test scenario, you now quickly had 6 or more test scenarios, one for each of the browsers that the test was driven on. This leads us to the point where we say that the test specification should not dictate on what platform the test will be run. So looking at the example to the right, a more concise way of doing this same functionality is using annotations to show on what platform and on what format your test will be run. So in this case, this will be Chrome, Firefox, Edge, and on large, medium, and small. This makes sure that you don't get this crazy boom of the number of scenarios that you see in your test cases, because it's easy to lose overview of the tests you have once you get too many of these scenarios. Onto a relevant point these days, with more and more teams going, more organizations going DevOps, more DevOps teams being created. We do not only want automated tests, but we also want our automated tests to become a part of a CI/CD pipeline. So as a team, we can gain quick and valuable feedback on the work that we are performing. But it also means that you need to make sure that your test suite is in some way, in an easy way, integratable in such a pipeline. One way that we have done this is, for example, by providing several test runners, with each test runner being responsible for certain tags or certain annotations. So the runner that you see here, for example, is responsible for every test scenario which doesn't have the ignore tag, but does have the large tag attached to it. And this means that you can run a subset of your tests, for example, in parallel. You can run and you can call your test runners in parallel in your pipeline, and you have control over which tests are run at what point in your pipeline. And the actual command to run your tests, in this case a Maven command, is very easy. It only consists of a couple of keywords, and you can add a lot of control to which test you're running by adding parameters to your Maven command. So in this case, we say through a parameter that we want to run our test on Chrome. And we can provide another command where we say we want to run our test on Firefox. And we can make use of the same kind of parameters when providing whether the test should be run on the test environment or on the acceptance environment or on development environment, that sort of stuff. Which brings us to already the last commandment, which goes into test reporting, on which we say test results should be easily accessible and give leads towards solving possible issues. So you want your test report to not only show which tests are run and which test passed and which failed, but also have your test report provide feedback to you whenever a test is failing. What steps can you take to make sure the test will be passing again? Where is the issue which made the test fail in the first place? So you can make use of a format such as this, which gives you a quick overview of all the tests that you were running, which of them were passed, but also an example such as this, where you can see on what format the test will be run, on what environment the test was run. And you can see here that one of the steps has failed, the when step in this case, and you can see a clear stack trace on what the issue was. And also very valuable at the very end, you can see those two attachments, which are screenshots, one of before the test failed and one directly afterwards. So you can directly compare the action that was taken to the outcome that was seen, which made the test fail. All right, which already brings us to the final slide and an overview of the 8 commandments that we define. You can see them here. I'm not going to read them out to you. You can read them on your own. And obviously, there's a recording of this session, so you can experiment with these in your own time later on. And yeah, which leads me to ending my presentation. And I want to thank you all for your attention. Also, one quick shout out to Mazin yet again for working with me on this presentation. And also, I provided a GitLab URL here on this page, which links you to a test framework that we created, which a lot of the functionality that I described, a lot of the options that I described in the commandments are provided by you by a framework. It's a Java framework making use of Cucumber and Selenium WebDriver. So if you want to take a look at it, if you want to use it, be our guest, basically. And that's it from me.